Within the culture that is DevOps, security practitioners are by now familiar with a privileged access management or PAM technology designed to help avoid data breaches when developers embed credentials in code, only for a threat actor to discover and exploit them. Application-to-application password management, or AAPM, has been around for a while. It allows DevOps to remove these credentials completely from code, store them in a password vault, and then obtain them programmatically at runtime. In this video, I'm going to explain how AAPM solves this specific security problem, only to introduce others that put your organization at potentially greater risk, and how Centrify Delegated Machine Credentials overcomes these challenges. So why are traditional AAPM approaches flawed? For human IT admins accessing a vault via a browser, the number of user accounts is contained and relatively easy to configure and manage. But with AAPM, for workloads such as apps and microservices accessing the vault, you may need hundreds or even thousands of service accounts, as well as something like an OAuth 2 client and API code necessary to log into the vault and consume its services. With each service account, your risk of being compromised increases, each one representing a potential vector of attack. So in a world where security best practices, analysts, and many regulations demand that you decrease the number of shared privileged accounts, this approach does the very opposite. Then there's the operational overhead. DevOps embraces speed and efficiency through automation. With traditional AAPM, you can't effectively embrace this model. Here's a typical set of manual tasks to enable a workload to access vaulted credentials and secrets. The overhead is potentially huge as well. So how can we enable AAPM while solving these additional challenges? In a nutshell, we don't bother giving the apps and services their own individual ID. We give the machine they're running on an ID, and with proper access controls, we let the apps and services borrow that. So we only need to do the account creation and permission setup for the machine itself. This is what we call Delegated Machine Credentials. Using the existing Centrify client, the machine is enrolled in the Centrify platform and it obtains a unique machine identity and credential. We now have a strong trust relationship, allowing the machine to authenticate itself to the vault to obtain services. A workload running on that machine can now request use of the machine credential to authenticate to the vault without requiring its own dedicated service account. It can then obtain a bearer OAuth 2 token and use that for subsequent calls to the vault, such as for checking out a secret. I'd like to show a simple example where I will enroll my Linux machine in the Centrify platform, then use the Centrify CLI to check out a vaulted database password, leveraging the Delegated Machine Credential under the covers. So with the Centrify client installed, let's just confirm we're not enrolled in the Centrify platform. Let's enroll it now to establish that trust relationship. Of interest here is this parameter to enable the Delegated Machine Credential capability and to scope which Vault APIs are allowed. In my example, I have one that enables me to do a Redrock SQL query and another one to check out the password itself. Also, here's the name of this machine as it will appear in the Centrify Vault UI. Typing the cinfo command once more now shows that the system is enrolled. It has a trusted relationship with the Centrify platform, and this is the service account that's been created for it. Let's pop over to the Centrify Vault now to see what's happening up there. If I navigate to the list of systems, here's the system we just enrolled. Navigating to its client profile, I can verify that the Delegated Machine Credential capability is enabled. Now down below that, we see the API scopes we specified during enrollment. So now let's go back and let's put this in action. Let's use the Centrify CLI application to check out that database password. The first thing I need to do, however, is obtain the identity of the database account by using a SQL query. There's the name of the database account. This -m parameter requests use of the Delegated Machine Credential. And we're specifying this OAuth scope to make the Redrock SQL query. Now let's take that database account ID and use it in another Centrify CLI call to execute the actual password checkout API call, again using the Delegated Machine Credential and specifying the appropriate scope. And there's the account password. So let's wrap this video up. What Centrify has done is to leverage our client technology and our cloud-first architecture to solve some of the major DevOps headaches that traditional AAPM approaches can't. With Delegated Machine Credentials, we're effectively federating access for machine identities and making PAM a first-class citizen within the DevOps pipeline through 100% automation. For DevSecOps, this checks all the PAM boxes. Agility isn't compromised. Workload and infrastructure operations are streamlined, and the number of service accounts required is reduced to practically zero, closing thousands of potential vulnerabilities. If you'd like more information about Delegated Machine Credentials or Centrify's broader identity-centric privileged access management solutions, please head to our website at www.centrify.com.